All right, moving right along, let's go back to that first slide again, and let's remind ourselves that this concept that if we're a first degree function, so if we're here at this guy, a first degree function, we would cross the x-axis at most one time. If we were a second degree function, like this guy, we would cross it at most two, third degree, 1, 2, 3, and fourth degree, 1, 2, 3, 4, at most. So from there, we come across this concept here is that, hey, we have a thing called synthetic division, where we can find the quotient and a remainder of a polynomial divided by a binomial. And so what I want you to see here, I want you to frame in your mind is that if I took, let's just say, let's do something a little bit easier. Let's do, if I did 7 into 37. All right, so 7 goes into 37 5 times. That's 35 with 2 left over. So remember, when you think about this right here is your quotient. This right here is your remainder. This right here is called your divisor. And that right there is called your dividend. Now, the main things I want to really focus on here are the remainder. That's kind of the main thing that we want to think about here. So, but it's the same idea. We got this long division we've been doing where we divide it out, we get what's left over, and then what do we do with it? We'll come back to that in just a minute. We have a method called synthetic division, and when I use synthetic division, I like to use an upside down division sign. All right, I put a little box right there, and we'll explain that box in just a minute. And I take my coefficients. So there comes that vocabulary. I take my coefficients from my polynomial. So I take my 1, comes from the front of there. Take my 3, leave a little bit of space. Take my 7 and my 5. So my 5 and that little line right there should line up. So that's like my last little spot right there. Okay. Remember, x plus 1 is a factor. I'm trying to determine, this is what we're trying to do here. We're trying to determine whether or not x plus 1 is truly a factor of this thing right here, of this polynomial. So remember, if x plus 1 is my factor, then x equals -1 is my possible solution or my possible 0. So when we do synthetic division, we don't use the factor, we actually use the solution, or we have to convert that over to a solution. So in this case here, we got that setup. So that's our setup to start us off. From there, and I'll tell you what, before we even do that, we're not going to do all of this particular problem right here, but let's just go ahead and set this one up. So my factors, or my coefficients would be -8, +7, -6, and 3. Put my little line right there. I have x minus 2, so that's going to be x equals 2. So I'm going to see if 2 will divide in. So there's my setup. All right, here's the procedure. The first thing you do in synthetic division is you bring down the 1. Then you take the 1 and multiply it by that number you brought down and place the product right there. So -1 times 1 is -1. Unlike long division, in this case here, we don't subtract, we add. So 3 plus -1 is 2. Now, we take the -1 times the 2, and we put our number right there. So that's -2. Remember, we add. So 7 plus -2 is +5. We take -1 times 5, and we put our value right there. That's -5. We add them together, we get a remainder of 0. Oh, did you hear that? That number right there is my remainder. So let's tie this back to what we're doing over here. In traditional long division, you say to yourself, instead of multiplying to start the problem, you divide. You say, does 7 go into 37? And if you don't know your multiplication facts, then you're stuck having to guess your way to it. But we know our division facts, so we take 7 goes into 37 5 times, because we know that 5 times 7 is going to give us 35. And then instead of subtracting, here we subtract and get positive 2. That number that's left over is called our remainder. That tells us, if we have a remainder right there, that tells us that 7 does not go into 37 evenly. Whereas if I did 7 divided into 35, that gives me 5. That's 35 with a remainder of 0. That means that 7 goes into 35 evenly, or more importantly, 5 times. Well, what we found out here is that since we have a remainder of 0, just like a remainder of 0 over here, that means that x plus 1 does divide into this polynomial, and that means that my graph does cross the x-axis at -1. So let's take a look at that real quick. So go plug this in your calculator. So go y equals, clear that guy out, take your x raised to the 3rd power plus 3x squared. Please make sure you're following along, plus 7x plus 5. Hit zoom 6, make sure your graph's nice and square, and say to yourself, hey look, that guy crosses through -1. Well, let's verify that. Let's go to our table. Let's go second graph, and let's go to -1 and see what happens. Well, at -1, I have a 0. So by checking in our calculator, we're using what's called the remainder theorem. The remainder theorem says that if you take a factor, x minus c, so in this case here, and that we took x plus 1, so that's like x minus c, we convert it over to a 0, and we plug that guy in, we plug in f of -1, then whatever you get out will be called your remainder. So we take a look at the calculator. That means that if I did f of -1, I get a remainder of 0. If I did f of 0, I get out 5. If I did f of 1, I would get 16. So that's what the remainder theorem is called, and you're going to kind of hear me refer to that as we go through. The factor theorem is the rule right here. So the factor theorem, and you don't have to have these theorems memorized, you're just going to hear people using them. The factor theorem says that if I have a factor, I can take that factor, I can set it equal to 0, I can solve that thing and find a solution that I can test. Alright, so let's finish this up. So what do I do with that? Because my whole thing was that I want to find all of the zeros. Well, right now, I have 1 0. So, excuse me, let me hit pause for just 1 second. Alright, sorry about that. I want to make sure I kind of was going the right direction with what I needed to lead you to. Okay, so at this point, here's what we know. We know that we have a 3rd degree polynomial. So that means that if we were to list out our zeros right now, let me give myself a little bit more room. If we were to list out what we know about our zeros right now, so we'll do zeros right here, and I'm going to go ahead and erase this. I'm done with this. If you have it on video, you can always go back and look at it. Okay, so I got my zeros. Right now I know that x equals -1 works. So as a factor, I know that x plus 1 works, that it divides in. When I divided that in, I had an x cubed. I divided it by a power of x. That takes me down to x squared, 1x squared as a matter of fact, plus 2x, right here, 2, plus 5. Now at this point, what we're sitting here and looking at is that we have a couple options. Okay, one option for us to do at this point is to say to ourselves, okay, well I got a quadratic formula. When I have a quadratic and I want to factor this thing, I got 2 choices here. I could try bottoms up, or I could use the quadratic formula. So those are 2 choices that I have right this minute as for me to be able to see if I can take this any further. So I'm going to try bottoms up first because it's just easier to do. So remember the bottoms up, we do product, sum, factor. We take the 1 out here in front, we multiply it times the 5. Oops, sorry about that. We take the 1 out in front, we multiply it times the 5. That gives us a product of 5. We take the sum, which is 2, and we say to ourselves, what are the factors of 5 that will add up to give you 2? And the answer is there doesn't exist any, because the only factors of 5 are 5 and 1. So that doesn't exist. So we have to use the quadratic formula. So remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we come back over here and we'll change some colors and we'll slip that in there. So we know right now that our a value is equal to 1, our b value is equal to 2, and our c value is equal to 5. So I say x is equal to a negative 2 plus or minus the square root of 2 squared minus 4 times a times c, all of that over 2a. And now we start simplifying. So x is equal to negative 2 plus or minus the square root. Do what's inside. When you do what's inside, you find out that it's negative 16 over 2. We simplify. We go back to what we were talking about, in a previous test. We simplify. We get negative 2 plus or minus 4i, because the negative comes out as an I. The square root of 16 is 4 over 2. We simplify this out one last time. We get x is equal to, remember that what's going on inside your head, I'm changing colors because this is what's in your head. You don't have to write this out. In your head, we know that that 2 belongs to both of them. So our final piece here is negative 1 plus or minus 2i. Because we can take that 2 out of the negative 2 and the 2 out of the 4i. So that gives us 2 more solutions, because off of that we get negative 1 plus 2i, and we get negative 1 minus 2i. So we come back up here and we plug in our zeros and we say, okay, we got x equals negative 1 plus 2i, and x equals negative 1 minus 2i. All right, so this is a situation where we get into it and we see that we have these negative or these imaginary solutions, and we've got to take these imaginary solutions and remind ourselves how we can put them as factors. So as a factor, okay, bear with me just 1 second here. This becomes x minus, and now we stick this guy in, negative 1 plus 2i. And I'm using color so you can see this. The next one would be x minus negative 1 minus 2i. Clean that up just a touch. Negative 1 minus 2i. Now, I feel pretty confident that my math lab is going to take those answers, but I want to remind you that what's going to happen here is that you got to remember that really what's going on here is that you're going to have a negative to distribute inside and change those signs around. Even like right here, you'd have a negative. But I'm pretty sure that my math lab will take it. You don't have to distribute the negative inside. So play around with it and see. So the question that you might encounter on this problem is, what are all the zeros? So to find all the zeros, we would have to do our synthetic division to take the first one out. Once we had the first one out, then we'd have to use some other method, whether it be bottoms up or quadratic formula, remember, and then look at what we have left over using one of those methods. Then we place them in our factors. So the other question might be is, well, what are all the factors? Well, there they are. 1, 2, 3. There are the 3 factors. All right, so there we are with basically using synthetic division to find all the factors, all of the zeros, in a case where we came out with imaginary solutions.